which is the subject of this talk. And there were two other printers, an HP and a Lexmark. So at Synactive, we worked on the three printers, and we got remote code execution on all of them. So the idea is that each device brings a cash prize and a variable number of points. So each printer that you manage to compromise brings $20,000 of cash prize, as well as 2 master of points. So you can see that at the end, the race was close because we just finished ahead of DevCore by only 2 points. So that was kind of fun for us because the issue was not really clear until our last attempt. So now I will let Thomas talk to you about the bootloader analysis.
Yeah, thanks. So to attack the printer, what do we do first? The idea is when you have the printer, you're trying to find where the code is executed so that you can analyze it. So we first extracted the PCB, printed circuit board, in order to identify what is present, and what we can do with it. We also found a UART connector. So I will talk a little bit. We found one interesting storage memory, the NOR flash. This will be the topic of the bootloader part. We can also identify the ARM CPU, quite recognizable in this case. We add an eMMC memory. We found out later it was a firmware storage. And we also see the 2 gigabyte RAM memory that is present below. So based on that, these type of chips based on what is printed on it. So I mentioned the UART. What we did is we identified the pinout. So we first tried to identify which pin is a receive pin, which pin is a transmit pin, using a ground from another one. And we finally found the baud rate for the console. And we were greeted, you can maybe see here, with a message from the boot of the printer. When we started booting, we obtained the message we see on the lower hand right. So we obtained the DryOS version 2.3, copyright canon, so it was quite interesting. We will talk about it later with Remy. So next, how do we obtain the actual code that is run on the CPU? We have a standard flash memory using a SOIC of 8 pin. So it's quite good we have standard format because we can easily use already existing material. Using the printed information on the chip, we identify the flash model. We obtain the datasheet regarding this flash memory, and we obtain the on the right hand the information regarding each pin correspond to what information. Using this information and the CH341 USB key, it allows us with a clip, we plug it on the flash memory, and using the flash RAM software, we can actually download using the SPI protocol what is stored on this flash memory. So using this information, we actually obtained ARM binary, not directly an ELF, of course, but well, code that we could load in IDA, and so we could start the firmware analysis for the bootloader part. What we found out in this bootloader is it is able to download a firmware to the eMMC. Download means you can obtain a firmware from USB and write it on the eMMC. We also obtained the information regarding where in the eMMC the firmware is written. And also another important information where the firmware itself is mapped in the memory when it is loaded and the code is run. An interesting thing also we found out is a deobfuscation routine. So the firmware may be encoded, obfuscated, so that you can't read it directly, but there is a routine that deobfuscates part of this information. But actually, the deobfuscation routine is rather simple. You provide it the buffer, here is the data, with the size of the buffer and an offset. And actually, depending on the offset, we map each byte and we do the following operations to obtain the clear text information. In this case, you just subtract the position inside the buffer, subtract 1. You write, write the data, you negate it, and you obtain the clear text byte. So using a buffer, entry buffer, you obtain a clear text buffer after this method. This is interesting because further, we obtain the firmware which was obfuscating this method. But now, how to obtain the firmware itself? We only obtain the bootloader. The flash memory only holds the bootloader. It's quite limited in space. So there are different ways to obtain the firmware. I said before, the firmware is actually stored on the eMMC. We could have actually gone the hard way using hardware, but the eMMC was a BGA chip, so it's not as easy as the flash memory previously done. And we could have other issues. There is an easy way. The printer is able to check for updates and download updates itself. So what we've actually done is set up an HTTP proxy and ask on the printer to check if there is a new firmware and actually download the new firmware. So we could retrieve the URL that were used. It's only on HTTP, not HTTPS, so it's rather easy. And we could also download the binary file, download it, and that would be written on the eMMC. Actually, after the point-to-one competition, we found out there is another easy way, even easier. You could download the tools, the Windows and Mac tools from the Canon support website, and they embed the binary file, the firmware itself. So you could extract the firmware from these downloads and start analyzing it. These binary files use a specific format that we describe and we'll describe in detail later. There are the two first container containing all the information, and the two last part containing what will be actually written on the eMMC. All these blobs actually hold a header and a payload, and so I will go in details with each of these. First, you can have a CEFW block. This is only the case if you download the binary file, the update, from Canon website. If you download it from the support with exe or Mac file, you don't have directly the CEFW block. The content, the payload is only GZ, and this content, once uncompressed, contains one-to-many NCFW blocks. These NCFW blocks are the data that are obfuscated with the routine we saw previously. The payload is obfuscated, the header isn't clear. And using this routine, we obtain from the NCFW, we obtain multiple NCA blocks once the obfuscation routine finished. So now for the actually interesting part, NCA block represents the data that is actually written on the eMMC directly, including the header. The header is present on the eMMC. You got different information, such as the date of, I guess, of release, eMMC address, where to write this block, and for the code part, you get the RAM loaded address that is present and some more information. And for the first block, so the NCA block 0, on certain occasion, you get content inside that is a SIG block containing signatures, cryptographic signatures of the other NCA block to ensure their integrity. And you also have multiple headers. They got no payload, just headers. And these headers correspond to each of the NCA block present in the whole blob here. So using this information, we can parse and write a parser. And so we write IDA loader so that you can open the bin file directly inside IDA, and it will parse the format and try to extract the important information. Here in this case, we can see that we're in version 10.03. We see the different blocks I mentioned previously. And actually, you can see the block that is found, the code block, using the address here that I previously mentioned. So right now, we started from 0 to bootloader, and we obtained the firmware, and we can start static analysis of the firmware.
Thank you, Thomas. So now that we have the main firmware, we can let the fun begin. So the firmware is a compiled version of the DryOS operating system. We'll talk a little bit about this operating system. So it contains ARM instruction. The firmware is quite big, so when you load it into IDA, when the auto-analysis ends, you have more than 100,000 functions, so it's quite a big firmware. So we decided to try if we could automate some stuff. And briefly, we found that a logging function was used a lot in the firmware. And this logging function is quite interesting because sometimes it takes as a parameter the name of the function where the logging function is used. So we wrote a simple script based on X-ray decompiler API in order to automatically rename some functions. And this allowed us to rename more than 2,700 functions and to see a little clearly what was going on in this firmware. Okay, so now let's talk a little bit about DryOS. So DryOS is a custom real-time operating system which is designed by Canon. So we know that they use this operating system for their printers, for their GSL cameras, and probably for other devices. We looked at, maybe 2 years ago, we looked at another Canon printer, the MX920 series. And we know that this printer is something like 8 or 9 years old, and it was already running DryOS. So we know that it's not a really new operating system. They've been using it for a while. DryOS is based on Micro Industrial Tron. So this is a Japanese real-time operating system whose specifications are publicly available. So like any kind of operating system, it exposes an API allowing you to create tasks, mutexes, semaphores, sockets, all these kind of things. So the printer that we analyzed was running DryOS in version 2.3 with the release number 59, and it was based on Itron 4.0. If we take a look at DryOS from an attacker point of view, it's kind of interesting because there are no mitigations. So the whole system is linked into a single module. There is no ISLR, so each address is predictable, like the address of the stack of a task, the address of every function that you could target, for instance. There are no stack cookies. There are no write or execute protection, so both the stack and the heap are executables. there are no security assertions such as the ones that we could find, for instance, in recent glibc on Linux. And there is no barrier between tasks. So, for instance, one task can access another task stack. The heap is shared among the different tasks. And obviously, there is no modern protection like control flow integrity. So this is kind of nice for us because we know that if we find a single stack-based buffer overflow, we can get a reliable remote code execution. So Thomas talked to you earlier about the URT. So it just told us that during the bootloader start sequence, some message were displayed. But if we just wait a few seconds when the bootloader ends its initialization, we got a debug shell that is offered to us. So this debug shell is called a dry shell. So it's built in within DryOS. And it's kind of nice for us because it includes a lot of commands. So for 413 commands, there is different kind of commands that are organized in 46 command families, such as system utilities, network, debug, and so on. So you can find like command like net start, ping, or this kind of thing. And this was kind of useful for us, especially for the exploitation part. Two commands that were quite useful for us were xday. So this allows to dump memory in an xdump-like format. So this is kind of nice when you want to dump a memory area. And the second one is xm, which allows you to modify a single byte, word, dword, and so on directly in a memory. We will see later how we used it. Another command which is kind of nice. So Thomas talked earlier about the different way to get the firmware. Another command that we saw after the exploitation was emmc dump. So as Thomas told us, the main firmware is stored on the emmc memory. So if you just plug the URT, you can have like the dry shell and use the emmc dump to simply dump the MMC and get the main firmware. So this is still another way to obtain the firmware. Okay, so now we will talk a little bit about how we start hunting for vulnerabilities. So the first thing that we tried to do was to discover the attack surface. So we simply run nmap scan to find all TCP and UDP ports which were open. And an interesting thing is that there is a custom HTTP server. If you look on Shodan for Canon HTTP server, you will find that some printers are directly exposed on the internet. So it's kind of interesting. The HTTP server also handles TLS. So the TLS stack also seems to be implemented by Canon. It doesn't seem to be based on an open source project like OpenSSL. Then we will find printing related protocol like LDP, which is a line printer driven protocol. We will find IPP, it's the Internet Printing Protocol. So this protocol is based over HTTP. We will find IPPS, which is basically IPP over SSL. We'll find JDirect, another printing protocol. And finally, two protocols which were kind of interesting for us are Canon MFNP. So this one allows you to create print or scan jobs directly over the network. And Canon CIDM, which is a Canon administration proprietary protocol, which is exposed on several ports. So you can access it in a plain text or with an SSL socket or also over UDP. If we take a look at the attack surface for the UDP ports, we can find protocols that are related to network and service discovery. So this is what makes the printer visible on a typical office network. So we'll find NetBIOS, SLP, WSD, as well as ZeroConf, which is a protocol based on Apple Bonjour protocol. And as well, we can find a SNMP, so the Simple Network Management Protocol. So what we can see is that there is a quite wide attack surface, and a lot of services are enabled by default. So that was kind of nice for us, because if there is a big attack surface, we're happy. So now I will let Mehdi talk to you about the CADM protocol and the vulnerabilities that we found inside.
Thank you. Okay, now we will present the vulnerability and how we managed to exploit it. So the vulnerability is a heap-based overflow present in the CADM service. It has been assigned the following CVE, and the vulnerability has been reported by ZDI to the vendor through the point-to-point contest, and a security advisory has been released by ZDI 2 months after the original report. Okay, so now what is the CADM service? Test. Okay, thank you. So now what is the CADM service? So CADM maybe stands for Canon Administration, because this service allows to perform several operations such as adding a new user, changing its password, creating a new job, or simply shutdowning the device. And we have identified 41 supported operations in the code, and we have also identified the format of CADM message. So here in the header starts with the magic CDCA, followed by the version of the protocol. We have also the operation code that allows to identify the operation type. And the format of the payload depends obviously on this operation code. And the rest of the fields are not important here. Okay, now the vulnerability is present in the check user password operation. And the funny thing here is that this is the first function that we looked at when we started hunting for vulnerabilities in the CADM service. We wanted to know if there is some form of authentication and how it takes place. And by analyzing this function, we were lucky because it was vulnerable. So in this function, at the top of this function, we have an allocation of an object of 428 bytes. And this function simply decodes the check user password payload presented here at the bottom of this slide, and copies into copies this the sum buffer of this payload into the inlined buffer of the allocated structure. So here in this payload, we have 3 distinct buffers along with their size encoded into 1 byte each. And this function simply copies this payload into the allocated structure without checking the size of the destination buffer. So here we end up with a heap-based overflow. More precisely, we can overflow the salt buffer and the hash buffer as well, and we control the size of the overflow and the data as well, which is very convenient from the exploitation perspective. Okay, now in order to exploit this vulnerability, we need to understand first how the allocator works. So CanSecWest allocator is a best fit allocator. It maintains a single list of 3 chunks, and a chunk is made of 40 bytes of metadata. It starts with the header starts with the magic free if it's a free chunk, or ALLC if it's an allocated chunk. The size field encodes the size of the chunk, including the size of the metadata, and the next field is a pointer to the next free chunk in the free list. Okay, now what happens when we make a call to malloc? The CanSecWest allocator will iterate over the free list and will pick up the first chunk that satisfies the requested size. The important thing to note here is when we make a call to malloc, if there is enough space left, a new chunk is created in the space left free. That is, if the chunk size minus the requested size is larger than the metadata size, a new chunk is created in the space left, in the remaining space.
And then the allocated chunk is unlinked from the free list and returned to the user. The allocation now, when we free a chunk, it is inserted back in the free list. Free chunk in the free list are ordered by their address. So when we free a chunk, we iterate over the free list and insert the chunk in its position in the free list. And when a chunk is freed, it is merged with its neighbor if they are free. Okay, now in order to simplify the exploitation process, we have implemented a custom dry shell command, #d, that allows to visualize the heap state. So this command simply iterates over the free list and then use the built-in xd command to read the memory at a given address, and then we use this command to dump the header of each chunk in the free list. So in this output, we can see that we dump the magic field, followed by the size and the next field pointer. Okay, now how we can attack this allocator. So the important thing to note is that there is no security checks at all. So we can corrupt any of the chunks metadata, and the allocator is happy with that. Our strategy was to corrupt the next field pointer of the adjacent free chunk in memory, so we can get an arbitrary allocation. So how we can do that? We can overflow the data and corrupt the next field pointer and make it point somewhere in memory where we have a fake chunk. The only condition here is to get, for our free chunk, is to get a big size followed by a null pointer to close the free list. And the goal here is to point this next field pointer somewhere in memory where we have, for example, function pointers. Okay, now here is our exploitation strategy. The first step is to shape the heap. The second step is to corrupt the next field pointer of the adjacent memory chunk and make it point somewhere in memory where we have our function pointer. The third step is to allocate the fake chunk in order to write there our shell code, and also corrupt the one function pointer and make it point to our shell code. And finally, the last step is to trigger code execution by triggering the path that calls our corrupted function pointer. Okay, now let's see how we shape the heap. So the goal here is to force the allocation of the vulnerable objects from a large chunk. So we do that in order to prevent the allocator from serving our corrupted fake chunk at an early stage. So the large chunk will act here as a workspace from which we will serve all non-relevant allocation. And how we do that? By performing an HTTP request. This will cause the heap to be fragmented into a large chunk, and this is enough for in our case. Now, the second step is to trigger the overflow. So here we craft a malformed check user password payload in such a way that we corrupt the next field pointer of the adjacent memory chunk. And we the goal here is to make this next field pointer point somewhere where we have the CADM data structure, such as the CADM state machine or the CADM handler. And the only condition here for our fake chunk is to have a large size followed by the null pointer to close the free list. Okay, now here we can see an output of a screenshot of IDA where we can see our fake chunk header where we have a very, very large size. This will allow us later to request a very large size and to pick exactly this fake chunk. And this large size is followed by a null pointer. And not far from our fake chunk header, we can see that we have the CADM data structure, and we will corrupt one of this handler. Okay, now, in order to allocate our fake chunk, we will use another CADM operation, the CADM echo operation. This operation allows us to send back identical copy of received data, and it is useful because it allows us to allocate a large packet up to 10,000 bytes So it allows us to allocate a large chunk where we control the size and the data. And now the final step is to code execution. So once we have allocated our fake chunk, we will write there our shell code. In our case, we will corrupt the handler responsible for processing the processing the CADM echo request, which gives us immediate code execution according to the CADM state machine. And we preserve the rest of the data in order to avoid early crashes due to a corrupted CADM state machine. Okay, now one of the rules during the point-to-own contest is to prove that we got code execution. So in our case, we decided to display something on the LCD screen. And to do that, we have to determine first where the frame buffer is mapped in memory. So by analyzing the bootloader, we found some related strings, some strings related to the LCD screen. And by analyzing the related function, we identified this address. And to confirm that this address is actually the mapping of the frame buffer, we decided to use the XM dry shell command in order to modify few bytes at this address and check what happens. So by doing that, we noticed that the color of the top corner of the LCD screen has changed. So this confirmed our assumption that this address is actually the mapping of the frame buffer. So the next step was to write a shell code that will simply read the raw bytes of the picture from a server, and then write these bytes directly into the frame buffer. And the last call here in the example in the shell code prevents the LCD screen from going to sleep. So let's see a little demo. And that's it. Now I will let Thomas conclude.
Thanks. So for the three of us, it was our first point-to-own participation, and it was really lots of fun, quite interesting target, and we really enjoyed doing it. And we earned some money, so it's also real good. With the rest of the team, we also succeed to be master of pawn, so that was quite a good success. Now for the perspectives, what we could have done or what we could do if we had more time. For now, our exploit doesn't do anything persistent. You just, well, send the packet and you display our Ninja on the screen, and that's all. If you reboot the printer, nothing, well, it's like nothing happened. So one perspective we could actually add is to overwrite the eMMC and add some new task, dry OS tasks, so that, well, once you reboot the printer, it's still corrupted and we still have hand on this printer. Quite interesting because, yeah, as we saw earlier, printers are not really looked for well, supervision, security supervision. So it's quite an interesting path to be on a company network. Another issue we have is for the point-to-own, we just display the Ninja and it's done. It's all.
Recording in progress. Recording in progress.
Working for the 10.02 firmware version. It's the exploit has been corrected post version 10.03. So now it's corrected. However, fun fact, when you request, when you look for update from the printer itself, the Canon server just say the last version is 10.03. So if you only use your printer, you will get a vulnerable version. Last update is vulnerable. If you download from the support site the exe or Mac for update file, you will be at the last version. So just a fun fact. We also include the IDA Python loader so that you can right away load the binary file into IDA and start reversing. And also we include the IDA Python script that we use to rename the function. You just have to first find the logging function, rename it. We use the logf name. And once you have this name, you can use the script so that every call to this function is renamed if we found the name of the function. So with all this, you should be quite set up to be able to go on researching vulnerabilities in this printer. Regarding the references, what information we used, actually different talks, previous talks from, well, Godu that was here just before launch, reversing a Japanese wireless SD card 0 to code execution that is using actually DryOS Itron implementation. There was also the THCon 2021 by Remy and others regarding another Canon printer, another model. And finally, on the slide, you have also the link to the specification of the Tron, so the base of the DryOS code. So if you want to go on further inside the OS itself, you can have a look at this specification. So this concludes our talk. I don't know if any of you have questions or remarks.
So we have a small presentation from the Ponton folks now. They're going to be announcing the winners. Let me just go get them. There's one. Are they in the room? They're ahead of me.
Thanks for the talk. Really good research, guys. Quick question. Did you guys have a chance to reverse engineer the patch that Canon put out after you disclosed to them to see what kind of controls they put in to prevent all of these chain attacks?
Yes, so we actually checked the last version and they added checks, size checks on the PGCC check password, check user password packet so that you cannot overflow anymore. They check each sizes, so you can't actually obtain as a heap overflow. So that's what they did. They also include other correction. We were not the only team to attack this Canon printer. There was also 2 other teams, and I believe their correction are also inside this new version, and maybe other development patches. So we haven't looked at the other correction, just to ensure that the correction is correct and that yeah, you cannot use it anymore.
Hey, thanks so much for the excellent talk. I was curious, how many people were working on this project, let's say more than 50% of the time, and how long did it take you from the moment you started to the moment you got a code execution?
So on this target, we were just 3 of us. And regarding the time, a week, yeah, roughly a week.
Thank you.
I know that at the Austin Pwn to Own, the 3 printers were HP, Lexmark, and Canon, right?
Yep.
Have you guys looked at Xerox Work Center machines?
Not yet.
So you're talking about how broad the attack surface is with all the protocols that are involved and everything. The Work Center machines have a embedded web server. They have a Windows server and they have a Unix server, because the printing service is run by one thing, the web system is run by another, and the scanning engine is run by another. And then all three of the operating systems have an integrated network that talk to each other. So if you're looking for an even better place to find vulns, check out the document center from, what do they call them? The work center from Xerox.
Regarding the Xerox, I believe they are not helpful to security researcher. So
yeah, another French guy looked at Xerox printer. It's Raphaël Rigaud, and I think that he found quite a few vulnerabilities within Xerox printers.
Okay. Well, we don't want anyone going to jail. Any other questions? I looked online, I didn't see any. So I think we're going to get ready for the next presenter here. We're a little behind.
No, what we're actually going to do
Oh, the
is
Pwn to Own.
Pwn to Own announcements.
Yeah.
We have some men with nice jackets. Okay, first of all, yeah. A tour de force showing from Synactive. So yeah, well done, guys.
Is that unmuted on the bottom? Is their mic unmuted on the bottom?
Let's remove that pin and get these guys.
Am I on? Okay, I'm on. Yes, we're used to seeing these guys, and we usually have a checkbook out when we do. So my name is Dustin Childs. I'm the communications director for the 0 Day Initiative. With me is Brian Gorentz, and he is the director of ZDI and the senior manager of vulnerability research. Am I saying that? I always get it wrong. For Trend Micro. We have just completed Pwn to Own Vancouver 2020. It is the 15th anniversary of our contest, and it was a lot of fun. So over the 3 days, let's first give you the numbers. We awarded $1,155,000 to the contestants. That's pretty nice. You can clap for that because that's a lot of money. It's a lot of cash. I need to double check the exact numbers, but I think it's 25 unique 0 days that we purchased, 21 attempts from 17 contestants, only 2 failures. Everything else was at least a primarily success. You don't have a mic, do you? That's okay. That's just me talking. But
yeah,
you might notice the jackets in our hand.
Yes.
There we go. So we have a title called Master of Pwn. That is the overall winner. The Synactive folks mentioned they were Master of Pwn back at Pwn in Austin.
Yep, I remember that.
Much like then, the actual winner is remote. So that's why I have this coat to hang on the Star Labs team.
Yes.
They ended up with, yes. They ended up with $270,000, 27 Master of Pwn points. Let's see if I can remember everything they exploited, because they had elevation and privilege bugs in Linux and Ubuntu. They had Microsoft Teams, and they had
Windows 11.
Windows 11, Ubuntu, Teams. What else? What am I missing?
I'm losing track.
Oh, VirtualBox.
Yeah,
Oracle
VirtualBox,
VirtualBox. Yeah,
yes.
they had a guest host escape for that. So great work. If you missed the Tesla exploits yesterday, the Synactive team was able to remotely take it over, flash the windshield wipers, open the trunk, flash the lights. That was fun.
Yep.
And Microsoft Teams, we had 3 successful Teams entry, and including the one from Star Labs, which is 0 click, right?
Yeah, I believe so, yes.
Yeah. So that one's kind of a cool
They're very
one.
scary because almost every corporation is using Teams now. So
And that just allows a ransomware to just like take over your entire corporation with no user interaction whatsoever.
beautiful.
Yay. So anyway, we just wanted to say, to let y'all know that the results, show you the jackets, show you the trophy, that they get this trophy as well. In addition to that, they get platinum level in 2023, the ZDI program, which is always nice. And say thank you to the participants, thank you to the vendors. We had some partners that would be Microsoft, Tesla, and Zoom, as well as our co-sponsor VMware. Thank you to them. Thank you to Dragos and CanSec, as always, great host. And yeah, we look forward to doing this again.
Yep. Another 15 years, hopefully. It'll be a lot of fun.
Yeah, absolutely.
Hacking satellites probably in the future. So
Who knows? Who knows? Hacking your neural implants.
yes.
Pwn to Own neural. That's what it's for. All right. So Brian, anything else you want to say?
No, just thanks for everybody who ever participates in the contest. I've been doing Pwn to Own for 10 years now. I've been working with Dragos for a long time on this contest, doing it all over the world. It's, it's great to interact with the research community, get a lot of 0 days. We do a lot of 0 day purchases investing in the ZDI program. And at Pwn to Own, we're focusing on a lot of the exploit techniques. And so we love reading the white papers. We love seeing the cool research coming in, the cars doing crazy stuff, the printers going burr, little ninja guys flying all over the place. It's a lot of fun. So, just thank the research community for participating in the contest, really making it successful over the years. And, our company, Trend Micro, is very much invested in the contest and trying to make sure that we're pushing research forward and defenses forward and trying to protect all of our shared customer bases. So thanks for everybody participating. Thanks, Dragos, for all the support over the years, and it's been a lot of fun.
Oh, one quick other thing. I just want to point out that it was actually the Synactive team. Remy is also the one who came up with the correct answers to my trivia. So I got the Xbox too. The correct answers were $10,000 was the very first Pwn to Own back in 2007, 1,155,000 this year. So we've grown a tad.
Just a little.
There were actually 3 correct answers for the second one. Last year, we gave away $200,000 for an exchange bug, 200 grand for Zoom, and 200 grand for a Teams. So any of those 3 would answer. And on Monday, I keep going to Monday. On Wednesday, the first day of our contest, we awarded $800,000, which is a 1-day record. So those were the answers. So thanks for them. And if you haven't gotten a challenge coin yet, find me as I'm walking around. I still have extras and would love for you to have 1 or 2 or 5 or however many I don't have to carry back.
All right.
Cool. Anything else?
No, that's it.
All right, great. Thanks everybody.
everybody.
And we'll see you next
Can we
year.
please have a big hand for these guys? The amount of work that goes into this competition is insane. And these guys make it look so smooth. So thank you again. And with that, I guess we'll just blast right ahead in our next presentation, try to get through what's going on in our day. So I think our next presenter is already in the Zoom, so we'll just punch up the Zoom over here. So if he wants to share his screen, he can. Here, he's already on there. Just hold on a second. Oh, I see. All right, there he is. Hello, Mr. Zhang, or should I call it, is Raki? Let's get it. I don't see, I hear audio. Yeah. No, you do it here. Yeah, it should be good. We're still not hearing you on the Zoom. Hello? Nope. We're still not hearing you.
What?
Oh, now I can hear you. But Zoom is. Oh, okay. Hold on a second. Let's see what's going on here.
Hello, everyone. The topic I want to share today is Palm Windows from low to system provided via RESTman servers. Here are some information about me. I'm a security researcher of Anti-Security Lightyear Lab. Let's start with the agenda. First, I will introduce details of RESTman servers and its role in remote access model. Then I will introduce its attack surface and interact method. After understanding this, I will introduce some vulnerability, some details of vulnerability I found. And finally, I will explain how to complete the full exploit through this vulnerability. Let's start. First, what is RESTman servers? Its full name is Remote Access Manager Servers, used to manage virtual private network connection in the computer. And the remote access client rely on these servers. Most of the code is implemented in RESTman's DLL. The servers will handle the RPC request sent by the application. We choose to find a bug in this model. First, it has existed in the, this model is a very old one. It has existed in Windows since the NT4 version, 20 years ago. Older code means the vulnerability may affect more version of the system, and the code may have not been written with much security in mind. This serves a low privilege process to interact with it, and can be elevated to system privilege after the take complete, rather than local servers or local network. Another special point is that users with normal privilege can start these servers. So, if our take fail and the servers crash, we can start it again for the next take, which will make our exploit very stable. So how does it work? User application interact with RESTman servers through RPC request. RESTman servers send an LCTL request to NDIS driver. The kernel sends the message to the target server through network protocols such as L2TP, PPTP, IKEv2. And the server pass message through some drivers, such as REST L2TP, REST PPTP. The forks of this part is the forks of this shell is on the part of the application interact with RESTman servers through RPC request. The first entry must be the export function of RPC as follows: port enum, device enum, get device configure, port get info. After after a simple reading of the code, I found that most of the RPC functions have very little content, except for REST RPC submit request and REST RPC submit request local. These two functions will enter server's request internal. There is a lot of code here to handle user input, and is a good entry point for bug hunting. A total of 157 functions have been implemented. These functions are stored in the distribution table. A basic structure of distribution table is as follows. The first pointer, handle function, used to handle user request. The second pointer, sync function. I understand that is a proxy function. It simply set some content and call handle function. This pointer is the verification function, which is used to first perform verification on user input. After that, there is a field named flag, as shown in the figure. All flags here are 3. There are 3 types of flag. Flag equal 1. Only server's request in process function can enter the handle function. We can call the handle function through RPC request. Flag equals 3. The function can be used by sending a local RPC request. Flag equals 7. The function can be used by sending a local or remote RPC request. So there is a risk of remote attack here. Regarding the interaction method, the common method is to construct the RPC request directly. The simple method is can be implemented by importing RESTman DLL and calling its unexported function named submit request local to interact. Next, I will introduce some details of vulnerability I found. First, I will introduce a very simple out-of-bound rate vulnerability and two type confusion vulnerability and use after free vulnerability. About CVE 2021-31947, its location is get trigger other data function. It will cause out-of-bound rate problem because user input is not validated. Before looking at the vulnerability code, we need to understand another function, set track other data. This function allocates memory to hold the data entered by the user. And the pointer and the memory size are stored in the connection object. The question about the connection object will be explained later. After that, let's looking at the get track other data function. It reads the content from other data pointer in connection object. We set through set track other data. Here, mem copy safe is used to prevent out-of-bound read problem, but it doesn't consider if the other data length is too large, but output buffer is small. It will cause out-of-bound read problem. This vulnerability is easy to find, and I understand that there must be more questions in this model. Vulnerability in this model. It can be fixed by adding a length check. Very simple. Next, share CVE 2021-34457. This location is device set info request function, which is a function in the distribution table. It will cause information leak problem because table confusion. First, look at the data structure of the request entered by the user. The first 8 bytes are the same for each request, and the following structure device name is used to index device object. Info name param num, param array. Param num is used to indicate how many param structures are in the request. The param structure has many passing methods according to its type field. Param num, type, and buffer. When type equals 0, it will be regarded as this as such a structure. But and when type equals 2, it will be regarded as this one. Buffer offset and buffer length. When checking for the param structure of type 0, no verification is performed. For the param structure of type 2, it will check whether buffer offset and buffer length will cause inter-overflow and out-of-bound problem. The vulnerability code is here. It believes that this param should be passed in the way of type 2, but in fact, the param input put by the user can be another type 0, which cause buffer offset and buffer length to not perform any checking, which cause resulting in an out-of-bound read of any length. Information leak can then be done through another function named device get info request. The repair method here increase the type verification of the param structure. followed by CVE 2021-21885. Its location is free connection and is not directly stored in the distribution table, but there are many call paths into this function. It will cause an AAF result, also because of type confusion. First of all, we need to introduce the user data array in the connection object. This array is used to save user data in some functions. The program will save some data to the user data array of the connection object. It will be taken out and processed in the future. I noticed that the V6 here, saved here, is not just poor data. It also contains some pointer. This data will, which means that when the data is taken out and taken out in the future, this data will be used as a pointer. But unfortunately, the user data array can also be set by the set connection user data function in the distribution table, like this. We can set any content to any index. So if we set user data at index 6, when the code takes out the data with index 6 and use it, there must be a type confusion problem. In the free connection, there is such a use. Code believes that the location of user data plus 32 is a pointer, and it will be released. This will cause a problem, this will cause an AF problem. The repair model is very crude. Microsoft directly remote the free line of code. Finally, CVE 2021-21947. Its location is in the create connection function, which can cause information leak because used after free. There are two most important object types in this model: connection object and port object. The connection object can be created by sending a create connection request. We can specify the name of the connection. As for port object, it is created during server's init, so startup. There are 9 port objects in total. We can create a new port object by sending RPC request. There is such a function named add connection port. It can bound the port object to the connection object. Look at the data structure of add connection port request. Very simple. Port handle is used to index port object. Connection handle is used to index connection object. The connection object stores the port object through an array named port array. The connection object can bound many port objects. The index value is the index of the port object in the port array. Here is the code of add connection port function. First, it will judge whether the value of index is greater than the length of a parameter array. If it is greater, a new port array object will be allocated according to the value of index. Then, save the port object at the index position. It also set the pointer reference of port object plus 428 to connection object. it seems that everything is normal. But I think of the process of free connection before. It will release the connection object, but where to delete the pointer reference in the port object? So I started to analyze the calling path of free connection. Here is the code of ref connection, call path servers request internal ref connection, DW ref connection. We can see that it call free connection. But in addition to checking the ref count of the connection object, it also requires that there is no port object bound to it. The another call paths look the same and have been checked. Most of the calls to free connection are checked on the code path. Check if a bound port object exists on connection object. But there is an exception. Create connection. Next, we analyze how create connection does it. First step, find whether there is a connection with the same name through the user input. If there is a connection object existed, try to release it. If not, create a new object directly. We pay attention to how to release it. After finding an existing connection object, it will perform a status check on all ports bound to it, require port object plus 28 equal 4. The third step requires that the process which created the connection object has existed. The last step is to verify check all port object on connection object, require port object plus 24 equal 1. And here it will clear pointer reference to connection object. When the port object is found to be bound to the connection object, it doesn't exist directly. It looks like use after free can be triggered as long as we can complete the above check. The first condition is very simple. We use process A, create a connection object, and use process B to trigger this vulnerability. The next two conditions seem to be related to the state of the port. After analyzing the functions related to the port, I found the code to set them, which exists in the port close request. We only need to send the port close request to enter this function. By setting A3 equals 0, the state setting can be complete. So why is this problem not triggered in normal interaction? I traced the normal one-time interaction flow through debugger as follows. Send the port open request, send the add connection port request. Here we'll set the pointer reference of port object to connection object. Send the port close request. It will set the port object state and clear pointer reference to connection object. Then it will finally release the connection object. It will not cause any problem. But if we swap the order of the second and the third step, we first send the port close request. At this time, there is no pointer reference of port object, but the state is set to the closed state. Then we send the add connection port request. It will set a pointer reference to connection object. Finally, release connection object. We can get a pointer reference to the freed memory. Next is a change in the state of the port in the debugger. 10 to 04. 04 to 14. After sending port close request, it can just pass the status check. We can see that the connection object that the pointer points to has been replaced with another object. Now that we have the use after free of the connection object, let's say if there are pointer we are interested in. There are many pointer used to save user data, and there are many functions. Many function can be used to read content from this pointer. Can we directly get AR primitive by faking connection object? The answer is no, because this process function reads the content of the pointer. I'll use found connection function to index connection object. When free connection is called, connection object was already unlinked from the connection list. We have to find out where the connection object used is obtained through the pointer in the port object. Get info request. This function can leak out the position of +16 and +144 of the connection object. Then, which object is suitable for placeholder connection object? It needs to have the following two requirements. First, the size is variable and selected by the user to ensure the same size as the connection object. And +16 and +144 to hold the pointer we want to leak. The answer is port array. Here, we can make the size equal to the connection object through a special index and put the port object at the +16 and +144 through special index. After that, we can leak the address of port 1 object and port 2 object. Next, let's get AR primitive. It's time to use CVE 2021-21885A. We use this vulnerability to free port 1 object, and then set track out the data request to allocate memory, fake pointer to connection object. Step 3, send get info request again. And then we get AR primitive. How to find the base address of kernel 32? We have AR primitive and port 2 object address now. We can leak its virtual table address. Then we can get base address of REST API DLL. Read its import table to leak the base address of kernel 32 DLL. Finally, let's get AW primitive. Since having the AR primitive, we can select the use after free object as the connection object. There are many pointer on connection object and port object to save user data. It is possible to fake these pointers through AF and AR to get AW. The answer is no. Because all code that set the user data is by allocating new memory to save user data, to save the data. We have another choice, hijack vtable. I thought of this way before, but I thought the program enabled the CFG protect, but in fact, it's disabled. We can find the code that port info request like this. Through the fake port object, we can hijack RIP, fake the library address and the DLL path string. Finally done. Since the servers can be restarted again and again, we can achieve a 100% success rate. Step 1, track use after free to get a pointer reference to freedom memory. Step 2, use port array object to fake connection object. Step 3, leak port 1 object and port 2 object address. Step 4, use CVE 2021-21885 free port object 1, get AR primitive. Step 5, use AR and port 2 objects address to get the kernel 32 base address. Step 6, fake vtable hijack RIP. Demo time. I hope that through this share, you will have a basic understanding of this model. For other researchers, to help you see where vulnerability are more likely to exist, and simply understand some primitive and object, which can be easy to exploit with some vulnerability. There must be more problems in this model. For example, it is remote attack surface. In addition to the code of the kernel passing message, the remote data processing will also be performed in the user mode in these servers. And there are many places where user data can be saved. The vulnerability I introduced is the problem of data copy during the saving process. But in fact, this data will be processed in the future. It may bring more vulnerability in the processing. In addition to response DLL, some code implemented in different programs, their code size is also worthy of attention. Thanks for listening.
There we go. Now you guys can hear me and the internet can hear me. So who is left on the Zoom? Here, let's go look at participants. You know what? I'll call you back. Let's see. In the breakout rooms, do we have anybody? Where is our next speaker here? Let's see. We may be running quick. Oh, are we supposed to have a coffee break now? I'm sorry, I'm a little, it's been a long marathon and I was up late. So I guess we're on a coffee break. So I just have to entertain the people on the Zoom. Yeah, yeah. But you know what? So that's something else I've learned at this conference is that when you're doing a hybrid thing with live stream, you should have something for folks during the breaks. I will fix that problem in the future. Coffee, virtual coffee. You know, would that be considered giving or punishing? All of the above. Yeah, turn on, let's do this right. Okay. I don't know if, you know what, so the one thing that we didn't do is we should have had an audience camera so that we could switch that to Zoom and have, so what I can tell you guys what I've learned from this already and what I will do in the future is these little wireless things are great, but they're fiddly and difficult to move around. Those pan tilt zooms are kick A, and we should have had one up there on the audience and somebody to run it and be able to somebody questions and boom, you know, like that. Because one of the nice things about them is that you can actually just preset positions and have them go click, click, click. So you just press a button and absolutely. Just you can stop right there. You've sold me. Roll. So, oh, we've done drone races here. I mean, so we did in the room right over there. We've actually put up nets and had courses, and I bought 16 drones and handed them to people who didn't fly drones before. And what happens with anyone you hand a drone? I've been flying for about 14 years, and I have a room full of drones, and I've done commercial drone research as a disclaimer. But you hand a drone to somebody, and the first thing they do is go crank the throttle, and it goes zzz, slams into the roof. They go, oops, cranks the throttle all the way back down. It slams into the ground, and then they do that a little bit before they kind of slowly get the hover, and then they go out of control and hit a wall. But when they learn to relax and fly, so we flew little tiny whoops, little tiny things that couldn't kill somebody if they ran into them. And we put them in an enclosed netted space with gates is what we actually did. But the drones would have too much noise for all this vibration, and you're lifting camera weights and stuff. So that the remote people can wander around, the little telepresence things. Yeah, I can imagine that. Huh. So that's interesting, but you know the thing that's most difficult to overcome is what this gentleman, you won the Scotch, right? The person who you're like our only participant brave enough to turn on video. So it oh yeah, okay. There's a bit we learned.
I was in the middle of changing rooms and going to the lobby there.
Oh, let's make sure, that's the other thing too, that's quite disorienting in Zoom. It doesn't really give you a lot of indication, unless it pops the breakout rooms at the very far end of that menu. And it's very difficult to sort of get to it if you're on a smaller screen and stuff. So like we had several people start presenting in the wrong spot, and there's some folks in the lobby right now. So maybe there are some of our speakers. So let's go move them.
Yeah, I was just trying to get to the lobby and check that out.
Sorry?
I was just trying to get over to the lobby and check that out when you asked me that question.
So the control room's still up. Pondone has been torn down already. Speaking of which, somebody's got to retrieve that station. But there's you can go in and check it out. And I've just lost my thought of what I was going to tell you guys, but I'll remember eventually. Oh, I remember what I was going to say. What the other thing we learned is that we originally had somebody to hang out in the lobby and just kind of greet and host folks who are coming in. So when you get lost in and do that, but they quickly get bored because you're basically sitting there on a Zoom by yourself. And even if you pay someone, it's very difficult to, it's just like a mind numbing task. So we need indicators, and you join breakout rooms, you should be able to pop up a dialogue or a little welcome thing or some kind of instructions or something like that, but there isn't. And yeah, and I think so. The only issue that is on all this is that if you're hanging around Zoom, and Zoom likes to take over your whole screen there, like unless you have a separate device for the Discord and a separate device for the Zoom, it's very difficult to juggle them. So I found I myself didn't. I was all over when we were doing Zooms and online. I was able to do the juggling, Discord, Zoom here, and do all that stuff when you're sitting in front of a screen permanently. But when you're wandering around and stuff, the Discord just didn't get any love from me this time. I couldn't even look at it because the Zoom was, and you've got dueling chat systems, right? And you face the same thing with all the pre-made conference systems too. They all have their own chat systems, and getting the notifications lost. While we used Signal as a backend for our stuff coordination, you got so many different channels. It gets like spectrum diffusion and becomes useless. I think actually I have to double check, but I believe we do not have any more in-person presenters. Let's look at what's going on here. Where I was going. The interesting thing about conferences is that you finally get everything working about right on Friday morning after 2 days of hiccups and whatever else, which is usually right about the same time you got to tear it down. Yeah. 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 Yeah, there is a lot of creep from year to year and architecture differences, in my opinion. Like the thing that was the messiest for us is when we first dropped in, we were doing all our streaming from the other room, and the hotel connectivity between us dropped, so we had to switch everything to Wi-Fi very hurriedly. And then it was a domino effect because all of us hopping on the Wi-Fi made Pwn streaming start to hiccup where it used to be solid, and it's you're playing moving games and stuff like that. It's stabilized. Eventually we figured out all the kinks, but by the time that came back, then the connectivity was here. So it's like we did by the afternoon go to our original setup, which has most of the stuff running over PoE, Ethernet, and cable wires instead of actually. Yeah. Yeah, the afternoon we were running everything with the PoE and running wired. So yeah, I think actually it worked okay. And to be honest, I hate the guy. I'm trying to break myself for that phrase, to be honest, because it implies that I'm rarely honest. But the hybrid stuff actually added an interesting dimension from the backside of the conference. I think I saw several people. Rob over there, actually, he's sitting out there in the hallway watching the stream next to the room, right? And I saw several people doing that. That gives you a little bit more freedom when you're mixing around and where there's something you want to see and you may not be able to get to it. So we'll see what we salvage from the recordings of Thursday morning, though, with the Zoom hiccups and everything else. So, yeah. So they published a huge update in that the afternoon, right? So I don't know what the deal is. You know, if I would actually been smart, I would have realized that probably there was somebody here from Zoom because of their sponsoring Pwn to Own. So if I would have had the rest to realize that, I could have looked that up and tried to find them and figure out what that is, but I don't have any information. So no, it's yeah. I had actually a lot of fun this year. It's that smaller conferences are more fun, even though more difficult on the organizational side. You know, it's. Pardon me? Oh yeah. So what I find. So when you have like 500 people here, there's a lot more little fires and little people that need different exceptions and interrupts and whatever else. With a smaller group, it's much less chaotic, I find, for the organizer. The biggest thing we ever got was just over 600, somewhere between 600 and 650, and that would have been 2019, 2018, 2018 or so.
Oh my God.
Oh, hey.
I'm on the big screen again.
All right. But yeah. Yeah, that was interesting. So, you know, we put a lot, so we learned a lot about the streaming stuff with incremental small efforts with the Pwn to Own things, these Mevos and some of these others. So there's a lot of gear experiments in all this, learned a few things not to do. Yeah, absolutely. Yeah, no, yeah. No, I don't think they're here yet. I'm not sure. So I suppose let's check some emails. Let's go to the second level. I'm being a little too passive, maybe. So our next PAP is MMO flaws lead to, it's a VM escape talk from Not yet. Anybody? Oh, Kihao Lee, he's here. Let's ask him to unmute.
Hi, can you hear me?
Yes, you can, and you're on a screen, and everybody can see you, and everything's quite nice, actually.
Okay, should I share my screen now?
Yeah, why don't you go ahead? And we're trying to make up time on the schedule, so if you're ready to present, we're ready to listen to you. Oh, are we? Hold on a second. Let's check the official time here. What's the break schedule agenda? And all right, so we're good. So yeah, let's go ahead and start the next presentation.
Okay.
And nice to meet you, sir, as it were.
Nice to meet you too, Dragos. I hope you can see my slides now.
We can, everything's great.
Okay, so let's get started.
Thank you, sir.
Okay, hello everyone, welcome to our presentation. It's called Matryoshka Trap. It's a Russian name. Recursive MMO flows lead to VM escape. In this talk, we will share our research on the recursive MMO in hypervisor. a new attack service that can lead to VM escape. So who we are? My name is Qiu Hao, and now I am a graduate student at the Harbin Institute of Technology. Gao Ling is a PhD candidate at Zhejiang University. Our research areas include system security and fuzz testing. This is the outline of our talk. First, I will try to finish it in 30 minutes so we can have some time for Q&A. First, let's give some backgrounds about QEMU and KVM. So KVM is a Linux module that makes Linux behave like a type 1 hypervisor. It can provide hardware-assisted virtualization to user space program. QEMU is an emulator program which provides virtualization of an entire machine to run a guest OS. This figure illustrates the high-level architecture view of KVM with QEMU. The virtual machine and QEMU run in separate threads. With the help of KVM, the guest OS can execute most of its instructions directly on the host CPU. But when it tries privileged operations like port mapped I/O or memory mapped I/O, it will trap into KVM. The KVM will decide how to handle those VM exits. Most of the time, KVM will return to QEMU and tell it why the VM exit. QEMU will then emulate the corresponding devices. So what is recursive MMO and what are the root causes? In QEMU, MMO is emulated by intercepting the memory access, and DMA is usually implemented by user space memory copy. Additionally, a virtual device can see and access memory regions of other devices, including the system RAM and the memory regions and IMMO regions. Since the guest OS can control the destination address of DMA, when it sets the destination to overlap with the MMO regions, the relative I/O handlers will be called during the data transmission. However, when the write to MMO operation forms a loop, it will cause problems. The MMO handler triggered by the DMA may have side effects on the device that launched the DMA. So when the control flow returns to the device, bad things may happen. For example, as shown in the figure, we set device A's DMA destination to its own reset register. So when it writes to the register later, its internal data structure will be freed. After the reset routine returns, since the I/O has not been completed, the freed data structure will be used, thus triggering a user after free exception. This phenomenon occurs as long as it forms a recursion. For example, we can also create an indirect recursion. Device A calls the MMO handler of device B through DMA, triggers the DMA operation of B, and B will then trigger the MMO handler of A. From a big picture, the incomplete isolation between DMA and MMO is the underlying cause of recursive MMO flows. Different CPU-to-device communication methods, such as MMO and PMIO, should not affect the DMA, because by definition, DMA is a memory-to-device communication method that bypasses the CPU. So in essence, recursive MMO flows violate the consistency of device state-machine transition. Therefore, depending on the design and implementation of different devices, the harm may also different. We give 3 common consequences here. The most harmful possible vulnerability is user after free, and it's usually caused by a pattern. Write to MMO reset register, free device internal data, use free data. If an attacker can occupy the released data between free and use, it's possible to escape the virtual machine. In some devices, structures like data transfer size and data index are stored in the device's global buffer, and these data are only checked before being used. So attackers can launch DMA to the MMO register that can modify this data. Then an out-of-bounds access situation will happen later. Attackers may achieve information leakage or control flow hijacking. Finally, The device may launch DMA to the MMO register that will trigger the same DMA action, thus forming an endless recursive call. Attackers can use this flow to crash the hypervisor. Besides QEMU, we did some experiments on the Oracle VirtualBox, and it seems also affected. Although this is only an artificial verification, we believe that the similar results can be achieved in the guest OS. We leave it as a future work to research VirtualBox and other hypervisors. You can read our white paper for more details. And some people may ask, why does the real-world hardware have no such problems? We think there are three main reasons. First, most hardware circuits works in parallel, so device re-entry will not occur in half of the DMA data transfer, which means it will complete all I/O operations without being interrupted. Second, the hardware doesn't have memory allocators similar to the software like the ptmalloc, so it may be hard to trigger a UF exception. Last but not least, the threat model of hardware devices is different from that of virtual devices. Suppose an attacker can control a hardware device to trigger recursive MMO, then he must have a high privilege. Then this kind of attack is not so scary. However, for QEMU, if the guest OS can control the virtual devices to do recursive MMO and achieve VM escape in the end, that will be a real security issue. Next, we will explain how to make the hunting and the exploiting process automatic with CodeQL. There are two common paths to trigger the recursive MMO in QEMU. From an MMO handler to another MMO handler, or from a button half timer callback to an MMO handler. To automatically find those paths in virtual devices with CodeQL, we first need to describe the characteristic of the MMO handler and the BH timer callbacks. As for the MMO handlers, it's defined in a structure called memory region ops. So we can just search each device's memory region ops object and get the MMO handlers. Here we only read handlers since most of them cannot trigger DMA. For button halves and timers, they are created by calling QEMU BH new for and timer new NS. And the callbacks are passed as the first and the second parameters. So we can just search those two functions in each device to get the BH and the timers callback. The last function we need to know are the write to physical address APIs, which implement the DMA. According to QEMU's documentation, there are a lot of such functions, like DMA memory write, PCI DMA write, DMA buffer read, etc. Actually, they all call to address space write in the end. So we can just search those functions for write to physical address gadgets. To improve the performance when searching, we hard-code those functions in CodeQL queries. Then we can use the path graph module in CodeQL to find all the possible recursive paths. We need to define our own algis query predicate, which is the core relationship, and the nodes, which is arbitrary functions. Finally, we can leverage the transitive closures in CodeQL to do the searches. For example, there is a path from MMO handler to PCI DMA write in the Mega read device. We said that there are three common consequences caused by recursive MMO flows: user after free, out of bounds access, and endless calling. Since UAF is usually easier to exploit, we only focus on this kind of vulnerability here. To find all the possible UAF flows, we need to load the possible path from an MMO write handler to a reset function call. Similar to previous queries, we can use CodeQL to do this quickly. For example, we can find a path from an MMO write handler to a reset function in the EHCI controller. Now we know three types of paths: from MMO handler to DMA write, from BH timer callback to DMA write, and from a MMO write handler to device reset function. To find devices which may have UF flows caused by direct recursive MMO, we can calculate the intersections of those paths manually. For example, if there are type 1 and type 3 paths in device A, then device A may have UF flows. To exploit the UF vulnerabilities, we have to find the malloc primitives which can occupy the freed chunk before it's used. There are two possible ways. First, the control flow returns from the after the control flow returns from the MMO reset handler, a malloc that allocates chunks the similar size as the freed chunk will be called. However, after some reviews, we don't think there is a vulnerable device have such primitives. Second, instead of calling malloc in the same device, we can write to another device's MMO region in which a chunk will be allocated. Then we return to the vulnerable device to use the freed but occupied chunk. Since scatter-gather DMA or vector DMA is common, it's easy to find the vulnerable devices that perform multiple DMA write operations. So we choose this method. So our new goal is to find a malloc that can be triggered by an MMO write, and the guest can be triggered by an MMO, and the guest can control the content of the allocated chunk. It's also best that the size of this chunk can be controlled by the guest OS. Based on past experiments, we get this primitive has the following characteristics. First, there should be a freed before the allocate call. Otherwise, the guest can keep allocating chunks and crash the hypervisor. Two data structures are usually used for data transfer between guest and the host: a linked list and an array list. To get size-controlled chunks, we focus on arrays which are composed of multiple constant size units. Third, there should be a read from guest action after the malloc call, so we can control the content of the allocated chunk. Last, the parameter of free read from guest and the return value of malloc should be the same pointer. Then we can find the multiple free malloc pairs. Here we discuss a primitive in the Intel HDA device. This free malloc pair in the function that gets the buffer descriptor list from the guest OS. The guest OS can read arbitrary content to the list. This routine is triggered by setting the run bit in HDA stream control registers. Moreover, the LVI variable here is also controlled by the guest. So by calling this routine, the guest can allocate any chunk size multiple of 16 bytes. Last, there are 8 streams in the HDA device, which means the guest can call several free and allocated primitives in one scatter-gather DMA operation. So this is also a perfect primitive to construct the heap feng shui. Using the code QL queries, we found multiple bugs. Here we will share 2 exploitable vulnerabilities. The first one is a UF vulnerability. In the NVMe device, DMA functions can be called without check if the destination region is overlapped with device MMO region, which results in recursive MMO. But what really makes this flow easy to exploit is after the reset finished, the NVMe enqueue rec completion will be called, in which CQ's timer is set to fire 500 seconds later. However, the timer is freed in the reset routine. Since there is a callback pointer in the timer, if the guest can occupy the freed timer, we can hijack the RIP directly. The second one is a stack overflow bug in the NVMe device. We found it when reviewing the previous UF bug. It's not a recursive MMO flow, but can be helpful later. This function transfers device log to the guest OS. The guest OS controls the variable off. If it's bigger than 4K, an integer underflow will happen, and the trans length will be set to buffer length. which is also partially controlled by the guest OS, thus leading to a stack overflow. Even worse, since auth can be set to any number greater than or equal to 4K, the PTR parameter of NVMe CQH can be set to an arbitrary address, resulting in an arbitrary memory read from the host to the guest. Last, the NSList buffer is used as a source data of DMA operations later, which can trigger the previous UF bug. So we can make the source data of the DMA operation from an arbitrary address, like the guest RAM we controlled. Leveraging those two vulnerabilities, now we will discuss exploit development and demonstrate a VME escape in the end. As mentioned before, we got a recursive MMO flow triggered by DMA that can cause UF, and the phrase structure contains a time pointer. And we got an arbitrary memory read flow which can be used to bypass ASLR and leak the guest RAM address. Last, there is a powerful malloc primitive in the HDA device. So our plan is the following. First, in the guest OS, we construct a fake timer and prepare buffer for the MMO write operations later. By leveraging the arbitrary read flow, we can leak the address of system at PLT and the address of the guest RAM. Since the content of the DMA write operations in the UF flow is from the buffer of the arbitrary read flow, we can make the source data of DMA from the buffer we construct in step 1. By leveraging those two flows, we launch scatter-gather DMA write operations to NVMe MMO region, and the first MMO write is to trigger the malloc in the HDA device, allocating 3 chunks the same size as the Cumulus timer, thus cleaning the T cache of the main thread. In the same DMA context, the second recursive MMO write is to the reset register of NVMe controller, releasing the CQ structure, which contains the timer. In the same DMA context, the last MMO write is to trigger another malloc in the HDA device, thus occupying the freed CQ structure, and the timer pointer in CQ now points to a fake timer we constructed in step 1. When timer mode is called later, the callback in the fake timer will be called. Since we control the callback and its parameters, a control flow hijack can be achieved. Here we briefly give some explanations. You can view our white paper for more details. In QMU, a memory region backed by host mapping memory will have a corresponding pointer in the heap. So if we can leak the address of the heap and search through it, we can get a guest RAM address. Luckily, after some reviews on the stack, we found a stable pointer that points to a variable in the heap, and its value is always below the guest RAM pointer. So instead of getting the base address of the heap, we can just start from this pointer. The next problem is how to find the RAM's pointer on the heap. We observed that the virtual address of RAM is always aligned to 40 megabytes when we set the guest RAM size as 2 gigabytes. And there is a stable pointer on the stack that points to a mapped memory region whose high address is the same as the RAM's high address. Last, considering that only 48-bit addresses are available, we can design 3 patterns and search on the heap in units of 8 bytes. Finally, got the address of the guest RAM. The right figure shows the process to leak the RAM address. When we trigger recursive MMO flows in the NVMe device, the DMA source data is described by a structure called PRP. A PRP entry is a 64-bit memory physical address divided into 2 parts: page start address and page offset. There are 2 PRP registers. PRP1 pointing to a page, and the PRP2 can point to a PRP list, which contains a list of PRP entries. This figure illustrates the PRP structure we use. As we said, we should trigger 3 discrete MMO writes. So we need 3 PRP entries to clear the T cache, to occupy the freed timer, and to corrupt the timer with guest RAM content. The reason that we must clean the T cache is that we found If the current thread T cache is full, the allocator will pull the freed chunk back to the thread in which the chunk is allocated. This will prevent us from occupying the freed chunk. After the recursive ML finished, a callback function named notifyCB will be called. Since the timer list is in the guest RAM now, we can control the notifyCB's destination and parameters, thus executing arbitrary code on the host OS. In this demonstration, we make the callback pointer. We make the callback point to system at PLT, and the first parameter point to the LOM calculator string. So a calculator will pop out on the host. So how to fix those flaws? There are two typical mitigations. The first mitigation is to add busy flag in every device. When we enter the MMO or BH timer callback, the busy flag is set, and when the IO operation is completed, the busy flag is unset. If the busy flag is set when we enter the device, an error will be reported. The disadvantage is that we need to add code in different locations for different devices. The left part of this figure illustrates the design of this solution. The second mitigation is to put the checks on the bus. By analyzing the data destination address on the bus, the exercise that can generate a loop is prevented. However, now we need to record all the devices that had been exited and release the records when it's over. The right part of this figure shows the design of this solution. The community adopted a hybrid solution which puts the check on the bus, but leaves the device to decide whether to allow writing to a long RAM area. You can view the links below for more information. Next, we will share the history of recursive MMO flows and the disclosure process. In 2011, the first bug which may be caused by recursive MMO was reported, but it didn't get in-depth audit or repaired. In June 2020, a security researcher re-reported the flow with an assertion failure triggered by father, but received no response. A month later, Alexander Brokov from Boston University reported multiple crashes. The community confirmed for the first time that those bugs are mainly caused by DMA reentry or what we call recursive MMO. At this time, the first CVE ID was assigned, and it's classified as DOS. It's classified as a delay of service. In September, the first version patch was submitted, but the merge was shelved in the end. After that, some relative crashes mainly discovered by the OSS files had been reported, but all of them are classified as DOS. On August 20th, 2021, we reported a recursive MMO flow in the EHCI controller and provided ideas for exploiting the vulnerability. 2 days later, the second version patch was submitted, but it didn't get merged for compatibility. In October, we reported a recursive MMO flow in NVMe and later sent the exploit details. Red Hat agreed that the design flow should be fixed as soon as possible. First, provide patches for the NVMe controller and merge future patches in the QEMU version 7, which would be released 4 months later. Finally, we'd like to share some thoughts about bug hunting and open source security. First, this design flow should be as soon as possible. And since the mitigation has little sorry, I can't hear my voice. Okay, so and since the method has a little impact on performance and only several devices are used on the cloud, the fix should be easy. Third, this flow existed in QEMU for at least 10 years, or more than 1 year just considering the large-scale appearance. For those bugs, all communication is public except the one we use to achieve VM escape. So if you are a malicious hacker, a fast way to attack an open source software might be checking its bug tracker instead of finding vulnerability by yourself. And for demonstration, for downstream vendors, they should not just follow the upstream patching, but also do offensive security research on it. Otherwise, they are likely to expose vulnerabilities to attackers for a long time. Last, when auditing the hypervisors, we should pay attention to different behaviors between virtualization software and the real hardware. We will release the VM escape code and a white paper on GitHub after this talk. You can view them for more details. And that's all for today. Thanks for listening. Yeah. I think we have some minutes for Q&A. And if you have any questions, you can message me or Gaolin on Twitter. Thank you.
Thank you. I'm just running to the main hall right now. Thank you very much for your presentations. Anybody have any questions?
If you have any further questions, feel free to message me or Gaolin on Twitter. We are very pleasure to answer questions. So I'll just stop my share now.
Sure. Oops.
Speaker here. Plus, even if they had your credit card, it'd be maxed out and wouldn't work at this point, right? All right, I'm gonna try to find the next speaker here. Our next presentation is going to be, oh, it's by the Dawn group, who is so mysterious that I don't have names for any of them. But they're gonna be talking about breaking out of the Android sandbox. Android sandbox is how all the applications are isolated from each other. And they've got a demo of a exploit that doesn't require a kernel vulnerability, but can break out of the user space. And then they're going to show how you can then take that user space exploit and chain it together to get a full compromise on Android 11. Pretty exciting stuff. Did we find them online? If you're from Dawn Group, join the ballroom meeting group. Nope. Or turn your video camera on and you'll pop to the top. We'll find you. Just Rob. All right. Well, I did see some chocolate bundt cake out there and some other snacks. Now might be a great time to go get some more coffee. Yeah, I'll try to track them down. Are you going to get a less exciting or more exciting ID this time? Oh, ID, not identity. Thought maybe you were going to go into hiding and get a new identity. Sorry, we just realized we got ahead of ourselves. The next talk is actually the exploiting relational and non-relational Java databases. So that's Zhao Yaozhen and Chen Hong Kong. I think I butchered your names if you're there. If you're online, can you unmute yourself and we'll get you guys presenting here? I'll search for you in the chat as well. They had a very short summary of their talk, which was learn about Java databases, exploit, and pwn.
So the deal there was that they're going to go through a whole bunch of techniques that are used for Java database exploitations, kind of as classes, was my understanding of the presentation. But hopefully we'll see them soon and they can tell us for ourselves.
I can't believe we're actually ahead of schedule now. We've been behind schedule all day, but now we're ahead of schedule. So they might not yet be here. I'm going to keep looking for them though.
That seems fair, actually. To be fair, there is, I think we're going to be good on schedule here. We're going to let folks hopefully get out of here soonish. Nice choice of music, Silva. Hey, Silva.
Yeah, Dragos.
Nice music. Hey, see you guys later. Say bye. Say bye to the conference. I'm on my way back. I've resolved all my lost items.
That is excellent.
Yeah, it was under my hotel room bed, so I'm not having so much of a freak out now. So, see ya.
All right, see you soon. I see, Rob, you've got an extra participant joining the conference here.
Yes, my boys are home from school.
We're down to a handful of people here in the room. Introduce them.
Ethan, you want to say hi?
Yeah, they've been very entertaining for sure.
Right here, you can say hi.
Get them to dance some more.
Hi. Sir, look in the camera now. They're all curious about you.
Here, let me show you the camera and show you who you're talking to. So let's. Hi, this is you've got. There's a few people left. And this.
Here we go.
Hi.
See all of us here.
Those are all people at the actual conference.
We got the Lockpick Village going here in the front.
No, we don't have enough. Yeah. Stop it.
No, this is a Zoom, so I'm about to try to log it out. So let's see what's going on here. Sign up. And I want to take over the entire Zoom. Wahahaha.
All right, we're back on Rob. You're being broadcast, Rob, everywhere. What was your son's name there?
Ethan.
Ethan.
Hi, Ethan.
Nice to meet you, sir.
Now he has the attention. Now he's a little bit embarrassed.
Want to know my favorite game?
What's your favorite game?
Ruby Lands. I do want to play Furniture Law.
can't do
It's right under, but at least want to do one level that I can't do.
Yeah, are you stuck on a level?
And I've stolen his usual gaming TV for the conference, so he's being very patient and letting me use the big TV instead of him having it for gaming time.
Oh, well, there's nobody here that would understand wanting to game.
He's being sarcastic, Ethan. He's trying to be funny.
We all really like video games
Yes,
here
very
too.
much.
So we understand your desire to get on the TV and play some video games.
They have an entire room at the conference center dedicated to games.
We had a big party last night that had video games.
Well, he's missed out on 3 days of video games because he's been very patient. He's going to get a lot this weekend.
Nice.
The 3 days is a long time when you're that age.
Oh, yes.
I remember when
Gray Diamond.
summer vacation used to be forever, and now it's like a year goes by in an instant.
It's nice to see you in person. So yeah, safe travels. Let's turn off the mic.
Well, we're still looking for our presenters. Do we have a phone number we might be able to wake them up with?
I know Gray Diamond.
What was that, Ethan?
I know Gray Diamond. Grade 1.
Do you know any jokes, Ethan?
Let me think. What do you call a dog that doesn't listen to you?
I don't know. What do you call
A
it?
cat.
Oh, good one.
Hey, you have a good future in comedy, young man.
Want to know how old I am?
Sure.
6.
Nice. That must mean you're going to school now. You're learning cool stuff at school.
Want to know the name of my teacher?
Well, we probably shouldn't.
Mr. Steve.
You don't want to give away too much information.
Why?
Well, because it's something you'll learn a little bit later, but it's about personal information.
Yeah, you have to be careful of who you're talking to strangers, and we still qualify as strangers.
Yeah, we're definitely strangers. Should we go back to DCG? See what DCG's up to here. Oh man, you're in orbit now.
Nothing much, just hanging out, waiting for the next presentation.
Is that a are those trackers on your headset? Do you work in volumes?
No, this is just track IR for games.
I work in the entertainment space and we put those things on everything, but mainly very expensive cameras so that we can then track the camera and distort the image on the giant LED walls.
Very cool.
Who else is on here? Anyone else brave enough to turn on their camera and participate? I see the NSA has joined us, but of course they're muted. Let's see if they
The NSA was hanging out in the lobby. They wouldn't talk to me.
Ask them to unmute. Who else is on here? No one else is brave enough to turn their camera on.
Okay, so I can now give you hostly powers because I've ganked the host from the control room here. So
Right.
I can
This
make
one
you.
is-
Why can't I do this?
Let's see, which account is this?
Why is this not letting me make you host? Anybody better?
I think you can only have 9 co-hosts.
Well, let's. Oh, we only have 3. So that's not it. They're all these accounts are on the authorized host list for this meeting, because that's why you got automatic co-host. But it's not letting me hand that over. So you know what I'm gonna do? I'm gonna leave the meeting. And it's gonna ask me who I can assign the host to. So let's do it that way. Now you should be host. That's a good question, actually. Well, it's one thing I have
feel
not
like
tried.
we're
is
pushing
closed
the
captioning and breakout rooms.
pushing the features and boundaries of Zoom.
Oh, we've been doing that for a long time. Never mind last year at Phone to Own, where they demonstrated the silent takeover without dropping the Zoom call. So
Let's see. Saw a new participant join us. Let's see if it's our presenter.
okay, you have hostly powers. I'm going to continue my equipment trudging.
Chris has joined us. Hello, Chris. Welcome.
I am not the presenter. I'm in the back of the room.
Oh, something feedback. No, I'm not. I'm muted and no speakers here. So, oh, my mic maybe. Let's try that. Turn it off.
All right, Chris, go ahead and talk. You can, if you want, you can even turn your camera on.
I'm in the back of the conference room.
We're looking for Mr. Chris with no last name. Let's see, remove pen. Oh, there's Chris. Oh wait, yes, I was going to say I talked to this Chris earlier. He looks like he's joining us from the subway, but he's still actually here. It's the US. Queens. I'm pretty sure that says Queens back there, right? There's the other Chris. Oh, Chris, you got to unmute yourself there. You don't like the music? Oh no, because I'm pinning between the people, so it doesn't use the music. Key off that. Well, I think we need to revert to telephone system to call our presenters. All right, stand by everyone. We're going to try to dial up our presenters and get them to join us on the conference here. Here's a little recent news from yesterday for everyone.
Silva, at this point, I think that we should see if the last presentation is around, and while we try to contact this speaker and the Dawn Security Group folks, I'm digging up contact emails for them right now. But if the next speaker shows up, let's just start with whatever speakers we have. Okay.
Recording in progress.
Does this work? Check 1, 2. Okay, now you guys can hear me. Hi. There you go. Let's go see what we can do. Find some speakers here. Okay, folks. At least now, okay, we're looking for flanker 17. Is the actual speaker that's coming. Let's see what's going on here. Send him a the let's go over here in the chat. How do you like my fancy auto tracking camera? I guess I can demonstrate this since everybody's bored and waiting for meetings to come, so I can show you this little doodad. It's pretty cool because I can walk around.
Recording in progress.
Hang on.
Yeah, I just joined. I just found the speaker's name. I sent him some email, and it's flanker he. Let me see. Let me paste that in the chat. The next presenter is supposed to be. There you go. Also, you know, while I'm showing off gadgets and stuff, because you're all bored. Oh, hey. Hi, I'm actually in front of the crowd right now on the projection TV, and that tracking camera is here, so I'll come talk to you in a bit. We're just trying to find a lost speaker. Let's go over here.
All right, so I got a pin up there, so I'll stay on the screen. Looks like we're streaming up there. All right, this is what we're gonna do. How many people know what these things are?
We got an unassigned participant.
All
Victory,
books.
hold on a second.
Information inside of
Yay.
them.
We have a speaker.
So what I'm gonna do is I'm gonna ask trivia questions.
No,
and
hold
you'll
it. Stop.
get a chance
Stop.
to win.
Hi,
Dragos.
Hey, how's it going?
Can you hear me?
Yes, we can
Malware
hear
data
you.
science. Oh, by the way, all of these books
Somebody
are
please
donated
just
by
tackle
Bill.
Silva.
He was here earlier. Bill's an amazing guy. He's been a
Hold on
long
a
time
second.
supporter.
Sorry,
of us.
I'm gonna
He
do this.
generously donated these. He firmly believes in education and the conference experience. So Bill's a great guy. So we're going to start with malware data science, attack detection and attribution. And my first question for the book is, what was the first computer virus that was first detected, and what network was it detected on?
Hold on a second.
Oh, before Morris.
Okay, sorry.
Hey.
Feedback. Hello.
I'm online now.
Okay.
Sorry,
So I'm trying to share the screen.
I'm using
He's pinned the video on the ballroom. Hold on, technical difficulty here while I run over.
It's pretty easy to tell because you can click on the talk page and see. Creeper. Yes, who said creeper? You want a book? Come get it.
Just a sec.
Yes, you're.
How can I share the screen? I find the
Just
option.
share the screen in Zoom.
Oh, okay, I got it.
Hi, nice to see you. Sorry, we're.
Let's see what else we
If
got.
there was some confusion about the schedule, we're running a little bit late. And Silva right now is just talking, and he's not noticing that we're actually here in the Zoom.
Yeah, I see he's very he's talking very happily now.
Yeah, he's
all right
into his own thing, so we'll get going here. Hold on a sec.
Free Unix operating system that was sued so that it could not be free, and that led to the release of a 386.
The reason you shouldn't pin the video is because when speakers and everybody in the control room come back here and are trying to interrupt you because our speaker has been online, that's why we should leave the Zoom unpinned and let it be dynamic. So yes, he's been on and we've both been yelling at you on the Zoom to stop, but it's okay. Let's do this. What you have it pinned? Let's go. Where is it?
I think we still have 7 minutes before
Just click on.
Well, I'm trying to, but I got to get this out of the way.
Gotta find the presenter.
Let's do it this way. Now you guys can hear me, and I'm here. Let's do this. Pin this. What are we looking at here? Oh, because this is a different computer, isn't it?
Yes.
That's where it's
I
pinned.
only pinned it here. I didn't pin this one.
Okay,
So
I think we can see your screen.
Oh, this one got logged out.
That one got logged out.
I will begin share the
Yeah, try sharing. I think we are seeing your screen right now in the main room.
Okay.
And I believe everybody on the Zoom can see it. Yeah. And we're picking audio from somewhere. Let's just, excuse me, folks, I'm just going to mute everybody. And then we'll restart all this. Where's...
Okay, let's see.
Okay, and let's unmute me.
Okay, is it possible to see the PowerPoint?
Yes, everybody can see you.
Okay.
Okay, sorry. Yeah,
Great.
okay, actually. Great. I think and the audio is good now, but I don't think anybody in the room here can see you, so I just have to feed the Zoom in.
Yeah,
Excuse me a second.
I didn't turn on the video because I'm at home now. I'm in
Oh yeah, that's
quarantine
okay.
in Shanghai.
That's cool. We've already had lots of kids visiting, for the record. We're a pretty kid-friendly place. But why am I not getting Zoom audio here? Let's try this. Maybe it's because I should mute it.
Okay, so when the audio stuff goes right, you can tell me so that I can stop in time.
You're good.
I think we have 5 minutes to launch.
Hi. Now, yeah, you can hear me now. We just had I just broke a mic, so I think you should be good to present now if you want.
Okay. Do I have to wait for another 4 minutes, or I can start now?
There's really nothing. We're all just a bunch of people here in the room and a bunch of people online waiting to hear.
Okay.
Us on
Okay,
Android.
now. Okay. So great. It's really different experience to present online. Yeah, because I'm still being quarantined in Shanghai due to the COVID Omicron situation, and I think some of you may heard about it. Yeah, so it's really a mess. So now I'm starting my presentation, Mistake in the House, a Droid vulnerability chain that owns all your user space. Firstly, I'd like to do an introduction to our lab. Our lab focuses on mobile system IoT product research, and we have Ponton winners and got some only award nominations and from 100 CVEs from Google, Apple, Samsung, and others. And for me, I'm the speaker at Black Hat, DEFCON, CanSecWest, Mosaic, and others. So our Twitter is Security Lab. Now it's today's agenda that we will first do a brief overview of the Android sandbox and its typical historical vulnerabilities. And secondly, I'll introduce the mistake chain, which is the core topic of this session, and how the chain is discovered. And thirdly, I will discuss about related vendor bugs in the chain and the static analysis technique we used. And the fourth part is the exploitation of the chain and how to detect it from a defender's perspective. And the final part is the QA. Okay. So let's give a quick overview of the Android sandbox, and I think many of you may have already have a knowledge about it. The Android sandbox consists of the DAC sandbox and the MAC sandbox. The DAC sandbox is controlled by UID, and you have like isolated applications have user IDs starting with U0, I1. You have normal applications starting at U0, A, 10,000 or others, and you have some special user IDs for platform processes like radio, Bluetooth, camera, NFC, and others. You have a UID with somehow high privilege like this, that is system, and you have the root user ID. And for the MAC sandbox, it is controlled by SNX label and policies. For isolated applications, they have isolated application label, and they can hardly access anything. And for normal applications, they have untrusted application labels. And for platform apps, they have platform applications and privileged application label. And also for special UID, they have special labels. For system processes, they have some different labels like system application labels, system server labels, and some bundle services have their special labels like key masters. And for root UID, they also have some different SNS labels like install D, UMD, VRD, or the high one kernel. So for the Android process label, I'm sorry, there's some noise here. Sorry, there's some noise here. Okay, I will start off. For previous research, we somehow consider system UID, example, especially system application UID somehow useless because it's strictly confined by the policy sandbox, because the only system server and the kernel can cross process boundaries. The last system server exploited bug, I believe, is in 2016 by Project Zero, which is bit on map. Kernel attack surfaces are also heavily researched and mitigated, and it's not very much to see or easy to exploit now. But today, we are here to make the system application bug, the system UID bugs great again. So let's now introduce the mistake. What's the bug chain? Why I'm naming it a mistake? Last year, a single line commit caught my attention that it is a commit in the Android 11, which goes into the official release of the version. I saw that they add a line policy for the system application .t, and you can see that they add a allow policy that they allows a system application to write to APK data file. So this is a very interesting change and why it is introduced. The Android R, which is Android 11 Preview 1, introduces ADB data loader as a supplement for the ADB incremental install. The ADB data loader is a system application that is allowed to modify application code. It is removed in the Android 11 Preview 4 and never made it to the stable. However, this policy change is retained. And another question is, who have the APK data file label? The label is for pre-bundled applications in the system partition by default read-only. For pre-bundled application in the system partition, it is by default read-only and have the system file label, which can be seen in the following screenshot. For new and updated applications in the data partition, the application space .application and SO files, which have the owner system, they have the APK data file label. And you can see that in the following screenshot for the com.example.galaxy store POC application, it's space.apk and its lib files have the APK data file label, which means that the policy change in the Android R grants system application the ability to write APK data file, which greatly enlarges the power of the system application and its vulnerabilities. Which means that now system applications can inject code, or whoever have the ability to write file as the context of system application, they can inject code into other applications by modifying their code. So it grants us ability like system server or root for controlling other processes. So following questions quickly come that the first one is, will these file changes be rejected by the certificate and signature check, which every application have? So for SO file, the package manager service won't recheck the integrity after it's installed. So it is a perfect persistent backdoor. For base.apk, the risk scan is not done until next reboot, which package manager service is reloaded. So, and also the hijacked code is directly loaded and started by Zygote as in the context and process space of the original application. So this picture describes that you add a single line to async policy and forget to remove it, and the whole sandbox will break. So this bug is reported to Google and assigned CV 2021-0691 and fixed in the September bulletin. And now, with this bug in hand, we need to find the file override bugs in system application to change it. We applied stack analysis on major window ROMs to try to find these bugs, and indeed we find a bunch of them in Samsung, Oppo, Xiaomi, and others. Actually, every major ROM, every major window have this bug to change to the mistake. So to find these bugs, we use a static analysis technique, which we try to solve the classic. It is actually a classic sort-to-sink taint analysis problem, and it can be solved under the FDS data flow framework on suit. The FDS framework is an interprocedure finite district subset problem, and we build it on top of FlowDroid, which is context and flow and field object sensitive. We find that the insensitive analysis sometimes does not have more overhead than sensitive analysis. The FDS approach works on interprocedure control flow graph, and we implement our analysis in 4 types of flow functions, which is the normal flow functions, call flow functions, return flow functions, and call to return flow functions. The normal flow functions is for like the flow goes to a normal statement, which is not a method invoke or not a method return. The call flow functions is for method invocations. The return flow functions is for which the function returns to its caller, and the call to return flow functions describes the data flow facts which is not included in the call flow functions. So we here have a question that will the grant URL permissions bugs on content provider works? With that, all researchers know that there exists a bug type for arbitrary file read write. That if you have access to control to an intent and control the flags, and you can combine the grant URL permission flags with an file provider to read write file. This is not the case for mistake because the file provider operates on file descriptors pass-through bundle, but it is labeled on the colors context, which means it is labeled on the attacker application context. So if an attacker attacks the grant URL permission box on file providers, the write operation is actually conducted within its own permission, which does not meet the requirement for the mistake. So back to our static analysis technique, we define source sink as follows. For sources, we have like intent and bundles. We define sources. The first category of sources are intent bundles and parameters from entry points, callbacks, bundle transactions. The second type of source is the data stream controllable, such as socket, controllable by attackers, such as socket. The third type of source is the files resources from controllable locations, such as the attacker package files or external storage or other attacker controllable files. So for the sink that can be for bugs that to find bugs that can be used for mistake, we define sinks as co-loadings such as stack loader, such as system load library, and the command execution such as runtime execute or other process builder. And the third part of the sink is the file IOs, like file output streams, data output streams, and others. When we apply our static analysis and build it on top of FlowDroid, we tackle several difficulties or problems that affect the preciseness of the analysis. The first one is the incomplete call graph. We know that the original FlowDroid analysis is built on Spark pointer analysis. However, for some special cases, for example, for some framework classes, the allocation is done in the framework code, and the Spark analysis cannot determine the allocation node, and causes missing edges in the call graph. And also, sometimes the Spark pointer analysis cannot handle cases. The default configuration of the Spark pointer analysis sometimes cannot handle the container analysis. So for the container analysis problem, we use the following approach. we have a minimum subset of the JDK, minimum subset implementation, which is the scope implementation of the JDK collection classes, and we incorporated it into the application, into the APK context to help Spark to discover the edges and the allocation nodes in the containers, in the collection containers. And for the classes allocation nodes that is in the native code or framework code, which is by default ignored by FlowJoy. For example, in this right side of the code snippet, if the parkable is retrieved from the get parkable, and later a function call is invoked, the Spark call graph will not include the function, will not include the p.func call graph edge because it cannot determine the allocation node of the A parkable class. To solve this problem, we use CHA approach, which I will discuss later. Also, we have some other problems that we have some incomplete call graph because some Android sometimes changes the component life cycles and introduce new entry point signatures here. So we have different component life cycle here, which by default will be ignored by FlowJoy and causes imprecise. Also, we have some performance tuning here that have some optimization for instance turning. We will drop 10 facts for instant fields if it does not have side effect. For example, because we know that the FDS is a fixed point analysis algorithm, so by default it will carry the 10 fact all over the FDS graph. So actually, for some 10 fact on the instant field, if it is not will not be accessed or read or written later, we actually drop the 10 fact for the instant field. And here for the Spark pointer analysis that it cannot determine allocation node in the framework class, we use a CHA approach, called hierarchy analysis approach, to add the corresponding edges to the call graph. So after we talk about the analysis technique, we will now discuss the real bugs. For the first part is the Samsung part. We know that Samsung is the leading vendor in the Android market after Huawei disappears. And we found at least 3 new bugs that can be used to serve the mistake chain in Samsung devices that we can obtain arbitrary privilege or arbitrary application from zero permission applications. The first one is the CV 2021-25450, which is the past traversal bugs in the system application factory error command manager. The factory error command manager is a system UID diagnosis agent. We use our static analysis tool and to scan this application, and we find some the scan reveals some high severity file IO bugs here. And so what's the actual bugs? We can see the analysis tool give us the propagation path on the bug. We can see that there is some propagation path from the Bluetooth socket module, from the socket stream to the file output stream, and it seems very interesting. It sounds very interesting to us. So the CV 2021-25450 is actually a fire override bug in the Bluetooth client and Bluetooth server. It is actually a Bluetooth diagnostic module in the corresponding system application. Its function is as follows. The Bluetooth client and the Bluetooth server provides modes for receiving files. And the file passes and content is controlled by incoming Bluetooth socket data, which is controllable by attacker. For Bluetooth attacks, we know that we will need pairing, Bluetooth pairing first. But in this case, do we actually need the Bluetooth pairing for the attacker? The answer is no, because the BT pairing is automatically done for us. On the right side of the code snippet, we can see that when a Bluetooth pairing request broadcast is sent, this system application automatically retrieves the broadcast and done the pairing for the attacker. So it is actually a bug that suddenly write out to controllable paths with controllable content. So for summary, the trigger path is in the Bluetooth socket server, which is created in the Bluetooth service of the system application. It is unexported. The Bluetooth service is created from final mode class, which is also a final mode activity, which is also unexported. However, the final mode activity can be started from the exported air command broadcast receiver, and the pairing is automatically done in the Bluetooth service. So for attacker, attack flow is as follows. The attacker first send the attack intent to the air command broadcast receiver to start the final mode activity. Final mode activity. The final mode activity will create the Bluetooth service. The Bluetooth service will create a Bluetooth socket server, and now the attacker pairs the BT socket, and it sends out a Bluetooth socket stream that starts with 80 plus FACM file, and follows by fire pass and fire bytes. And we can see that in this right side of the code snippet that the fire pass and the fire content is fully controlled by attacker. So it can use fire traversal to write to arbitrary fire location with arbitrary fire data. So it is a perfect system application privilege fire override bug. There's another path traversal in the factory air command manager that has similar flow. So we will not elaborate more here. We also have another interesting bug chain in the Samsung that can help us to gain the system application file override privilege. It is CVE 2021 25510 and CVE 2021 25511. It's actually two bugs combined. The first one is the Samsung camera privilege escalation, and the second one is Samsung filter provider path traversal. The first bug helps us to gain code execution in the camera process. The first bug is like when a package with com.sec.android.camera.permission use effect filter is installed, the system application filter provider is automatically notified, so it's registered to broadcast receiver and recognize it as a camera effect filter. The files in the target package is extracted to the date/downfilters/lib64 directory, as it can be seen in the right side of the code snippet. However, question quickly arises that which type of files will be extracted. We can see that there is a .so directory extracted, but will all SO files in arbitrary applications be extracted? The answer is no, because although the text and the SO file will be extracted, for SO files, a signature file that is accompanied will be signed and verified by the pre-built Samsung RC public key, or the content provider will refuse to extract and insert it. It is originally intended to be used by Samsung Galaxy Store only, because Samsung will verify and vet the applications and sign it with its own public key. However, very interesting or funny discovery here is that it does not verify the SO, the uppercase SO suffix. So sorry. So it means for us that we can craft an attacker application and bundle it with the uppercase SO file, and it will be happily be extracted by the filter provider. And if filter provider accepted, the camera when the camera application starts, the camera effect filter is loaded when user opens the Samsung camera application and uses the magic effect. The camera application will query the content provider and load all the executable files in the corresponding directory. And as we already use the uppercase ISO file to bypass the signature verification, now the camera process, its lib camera effect processor GNI ISO will happily load our executable files. And now we got code execution in the camera process with the right effect filter permission. And now it opens up ways to access the My Filter service in the filter provider, which will originally needs the right effect filter permission to access. The My Filter service protected by the signature level right effect filter permission have a typical path traversal and runs in the system application. As it can be seen in the right side of the snippet, that it retrieves the file name parameter from the bundle and directly concatenated to file path and write and did a file overwrite from the attacker's supplied byte array. So it's actually protected by the signature permission, so it's not a very big case. But as we already obtained the permission on the camera process, which have the right effect filter permission, and now we have we can now exploit the bug. So the whole attack flow is like follows: that the attacker, which actually malicious filter applications, it attacks the filter provider's filter installer and writes into the filter provider database, and the camera process, upon open, queries the camera filter provider database, and actually, and the attacker code will now be loaded and write malicious file into the by exploiting the filter provider My Filter service, and now gets system level file overwrite in the system application context. The upper part, the upper bug of the mistake chain is also somehow interesting bug, is that it's an LPE for mistake in the OPPO for identified as CV 2021-20243. The content provider exported with a call entrance which loads external plugin but without sufficient validation. External plugin is called by the DEX class loader in the host process, which also runs in the system application context. So attacker can fake a plugin to get code execution in the host process. We also have a mistake. We also have the bug for the mistake chain for the Xiaomi. It is actually a zip path traversal in the PowerKeeper application. Unfortunately, it's a duplicate with a Google AVPI program report, which they assigned CV 2021-04-0501. It's an insufficient validation in unzipping. So we have now introduced the vendor bug chain that we can use you can use together with the mistake bug. So a conclusion here is that the conclusion for the mistake chain is actually that the untrusted application, the attacker's untrusted application attacks the system application, and now the system application and use the mistake bug to overwrite the ISO files toward the base.apk files, the code files in other applications to get code execution. So this is now the explanation for the mistake bar, the vendor bars, the analysis technique. And now we will go to the post-exploitation. So how can we design a real-world practical attack using the whole chain? So given the present chain, how can we actually turn it into a practical control over other applications? So recall that we can override the two kinds of files under the data application, the dynamic library and the base.apk. And also we recall that the changes on the dynamic library is persistent until next uninstall or update. Changes on the base.application is persist until next reboot. But changes on the base application is easier because we can actually just do a smartly repackaging. It's somehow easier than injecting the dynamic library. So for the first type, we decided to, if we want to change our dynamic library, we will choose to inject a Frida gadget for our convenience. For the dynamic library injection, the ERF patching is needed to preserve the original function of the target so that we will not crash the original victim application, or it will not cause some disturbance for the user to call the user attention. I take Telegram as an example. We use the LREF framework to inject the needed entry in the dynamic section of the leaf tmessage.38.so, and the Frida gadget will be loaded automatically. So we can see that after our injection, we have a leaf Frida gadget in the victim SO's needed entry. There are still some questions here left to unleash the full power of the mistake, because the Frida gadget mode needs a configuration file and an instruction script to work. It needs like a leaf Frida gadget config for the instruction script parts, and which contains the instruction script parts, and also a Frida script JavaScript for the actual holding code. And the leaf Frida gadget needs to be executable readable for the victim process. And the process running the leaf Frida gadget must be able to write the configuration files, and must be able to read the configuration file and the script files. So the challenge is, as we did not completely break the sandbox, we only found a hole in the sandbox, and how to achieve it stealthily and stably. It's like dancing in the shackles. The first idea will come to us is that can we put all these files, all this Frida stuff in the external storage? The question is here that the victim application may not have the storage permission, so it will not work perfectly. The second solution here is that can we place these files in as the word readable files and word readable files in my own application data directory? Unfortunately, the global writable files for applications is disabled since API 30. So this will not work in neither. So to unleash the full power mistake, we come up with a solution that we pack them in our own applications library folder. As we know that application library folder is globally readable, executable by everyone. And for past changes required in the configuration file, and we know that from the right side of the screenshot, we can see that Android now have a random path for the application library path, So for the path changes required in the configuration files, we use mistake to attack ourselves to update our config. So and now we finally make the configuration file points back to the Frida script in our own application lib file. So the whole attack flow is like follows: we release and patch the Frida gadget configuration file and victims SO based on the obtained application parts. And now we point the victim entry back to the Frida gadget in the attacker path, and we point the configuration entry back to script file. And then we copy them back to the attacker's library folder. And the third step is we copy the patch target SO and overwrite the victim's library file. And finally, we will launch an attack. And the whole attack flow now flows seamlessly. So here is a demo. We use a mistake chain to obtain the privilege of actual application and use Telegram as an example, at the newest time of the discovery at that time. We can see that after we start attack, Telegram is controlled and we inject toast is injected. And the message sending is also hijacked. And then here is the demonstration of the reverse shell we got on the Telegram.
At this point in a real conference, we'd be applauding.
Okay.
So a virtual hand for you, sir.
Thank you. So we can see now we have the fire access on the because we already got the shell. So the final and the last part of the presentation is the detection from the defender's perspective that if you are an AV vendor or a researcher that want to detect that if your phone or your user phone or your employee's phone is detected, here's my source here that unlike traditional routing exploits, mistake does not have kernel as use of traces.
Most of the torn down looks like so. I guess
So the traditional routing detection mechanism will not work.
What am I normal
Setting
camera
that
setup
and
is. Actually, I'll share this
other
for
race detection
while
as
we're doing
DGAs
demos.
may
Actually,
also
that's the
fail.
one that's recognition. We use those at SAMs.
Yeah, so but I regret not getting the
timestamp
HD
is
version
a
instead
clue.
of the 4K version.
The mistake chain is to modify the application library
when you have actually a chance of
profiles.
putting some other
So
things
you
on
can
the same
scan the all last modification timestamps
and
of files in the
I don't know that
application code
you really
directory.
get that much in
And the files with
4K
abnormal
over
timestamp will
stream
show
these
that
days, you know.
the application
So
might be
yeah,
detected.
I have a little bit of remorse about
And
that.
the tracking's pretty decent.
We have released the
I like
detection
that.
And
to
but the recognition
our
sometimes
website.
Yeah, it's a little, but it does really well.
when you're teaching it, it stops tracking because you raise your hand, you point at something.
That's an interesting gotcha. I never thought of that.
I would say about
okay. I
half
think
the
the drug
time,
was talking about something.
I walk out of screen because at some point I had, got
Yeah. Well, so I normally I do like some preamp with like a couple of cameras ahead of time. This is my fancy.
Presentation is over, and
let's not do that over there.
so the conclusion here is that the mistake is a new type of innovative chain that can obtain arbitrary application privilege from zero permission application. Stability is somehow similar to kernel.
Hopefully, I can get it from the other cameras.
So it may evade a traditional detection mechanism, and we will have both ways to find possible exploitation. So we have some credits here. For the final part of the presentation, present to some researchers, and also thank the Google and Samsung mobile security and Oppo and Xiaomi security team to work with us quickly to resolve the bugs, and also the SUS and FlowJoy community and develop.
So that we can switch.
That's all. Questions?
By feeding the feed out from the switcher, and we do the upstream streaming from this.
I'm not sure if I can get questions from the conference hall. So, if you have some questions, you can reach us on the Twitter or we have websites you can consult. So
can you hear us? We're gonna see if there's any questions for you here. We'll take questions.
Yeah.
Okay. After I said that, nobody's got a question.
So yeah. Okay. So I think that's all for our presentation, and I will stop here. So thank you. That's all. Thank you all.
They were clapping loudly. They enjoyed your talk.
Oh, that's nice. Thank you very much. It's what a pity I cannot come to Vancouver on site.
All right. So hopefully, so we've skipped over the exploiting relational and non-relational databases. So let's see if that group has shown up in chat here.
For that talk, I have contacted the author, and he said he did not get the instruction email from the organizer. So do I need to call him to arrange a presentation now?
Yeah, so if you want to call them, all they need to do is join the same online meeting. And
okay, I will call him now.
And then they can join into the breakout room, conference ballroom, and then start sharing, and we will see them. All right. While we're doing that. All right. So I just randomly picked a page here. What is the generic bit bucket storage system in AWS cloud computing called? Generic system in AWS.
Okay. I have contacted the presenter for the relational database, and he said he is not available on the computer, and he asked if we can share a recording afterwards and the PowerPoint, and he may not be able to present right now.
He's not available to present right now.
Yeah, because it's like the first time, and he's not available on the computer because he doesn't get the arrangement email.
Okay. Well, we will. Does he know when he would be available? Can you give us a time when he'll be available?
Okay, I will ask him.
All right. Nobody got the question. Generic storage. There you go. S3. Very good. Who said it first? S3. There you go. How to hack like a ghost. Hacking cloud computing.
Also, sorry about interrupting you folks there. I didn't know that the mic was hot.
He said he might not be available this whole day, so we may not need to wait for him. So he will try to deliver a recording afterwards, or to send it to the conference committee.
Sure. Well, if you send me the recording, we'll stream it out over YouTube and send everybody an email notification about it if you'd like.
Okay. Fine.
Yeah.
All right. So earlier today we had a talk about capturing packets from the kernel. What was the name of that packet capture system?
I think we might have to make it a little harder.
Okay. Since a bunch of people said it all at the same time. It's BFP, EBFP. What does that stand for?
Isn't it EBPF?
EBPF, which stands for? There you go. You have just won yourself attacking network protocols. Well, Now you will because you have a book to teach you about network protocols. What is a computer language that's named after a snake? There you go. You have Black Hat Python. This is actually a really great book, Black Hat Python. It teaches a whole bunch of really cool practical hacking techniques and pen test techniques using Python. What else we got in here? All right, here's a book on practical binary analysis, like disassembling and looking at binary code. This is a book on how to do it with Linux. What is the name of a very commonly used software in Windows for binary disassembly and analysis? IDA. There you go. IDA Pro. You should tap that. Also, that one probably we're thinking on too. What else? What is the type of cat that serves up web content? Tomcat. You already have a book, though. Who else said it? All right. Let's find another question here. Client-side data is stored by the browser in something that's sweet. What's it called? I'm trying to get rid of them quickly. It's not being successful.
Let's take a different.
Yeah.
How about we go here? I'm going to keep this one, and while we just put these up here, and you folks would like to, Bill Pollock graciously provide these. Come up with
I was also trying to fill time until the other presenters. All right. So it's a free-for-all now. How Linux works?
The simple one.
Basic for hackers.
That's what I'm screaming of it.
This one will go. This one would go with your other one if you want to trade.
No, I already had one, so I don't.
Yeah.
We're giving away free books. An echoing. And I'm not feeding back. That's
practical hack analysis and web security is what's left. Nobody's interested in web security.
I was hoping to win a book. You can send it with my scotch.
It's okay. Let's thanks for you all sticking around to the very end. Let me actually put this over here. So this is kind of like the last bunch of folks. You all have safe trip home and everything else. And thanks for joining us online. We'll get whatever we can salvage the recordings from Thursday morning online, and some recordings from today as soon as I get some sleep and some time in editor. Thank you all for coming to this grand experiment, and I had a great time. Cheers. So,
Thank you.
no, it's over. Don't unplug. Okay. All right. So yeah, I'll say goodbye to you folks online. Cheers. And I will. I'll say bye to all folks. Cheers.
Test. Test. One, two. Test. Looks like it's hello. Hello. Test. One, two. Test. Test. One, two. See, the mic is working, but there's no sound coming. Test. One, two. Why? Test. One, two. Test.
Be around drive. It's a 40-minute drive out of town.
Test. One, two. Okay, this was fine.
Recording stop.